Hello everyone. In this particular lesson what we're going to do is we're going to use some trig angle addition identities to help us find a simplified answer to some right triangles. They use basic right triangles 3, 4, 5, but when you're doing that it's going to be important that you kind of write some things down. So I'm going to go over to this little trig identity reference chart and make sure I go over to the angle addition, and if you scroll through this I would just write these down in your journal. We're going to be using these formulas right here. The angle sum and difference identities, we're going to be using these as we solve the problems. So always helpful to have those handy whenever you're trying to solve these particular problems. So right now what I'd like you to do is I'd like you to draw this triangle, and it says find the sine of angle ABC minus 60 degrees. Alright, so we're going to be finding the sine of angle ABC. Now ABC is referring to this angle right here. Alright? And so if we're trying to find the sine of angle ABC, basically it's saying what is the sine of B? So the sine of B is always the relationship of the opposite side in relationship to the hypotenuse. So the first thing I always like to do whenever I'm just solving these problems, I just draw a little arrow going across for my angle, and I label that my opposite side, which means this 5, obviously this is our hypotenuse, so I'll put HYP, and 3, that's going to be considered our adjacent side. That's our, call it ADJ, our adjacent side. So the sine is the opposite. Try to do a neater job here. The sine of angle, I always make a little arc over there so you don't think it's an L, of angle ABC is equal to the opposite side, which is 4, over the hypotenuse, which is 5. So I know the sine of angle B, angle ABC, is going to be 4/5. Okay? If the sine of angle ABC is 4/5, what would the cosine of angle ABC be? Well, the cosine is the adjacent over the hypotenuse. If you remember SOHCAHTOA. There we go, SOHCAHTOA. So sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So the cosine is the adjacent over the hypotenuse, so our cosine would be 3/5. There we go. Alright, so what I'd like to do is I'm going to go over to my little identity chart right here, and I'm going to use the sine of theta minus phi, this right here, except I'm going to change this to x and y. So I'm going to take this right here, except I'm going to write it in terms of x and y instead of the theta and phi. So instead of theta and phi, which is, I'm just going to use x and y. So here we go. I'm going to write the sine of x minus y equals. Now just we're going to take our time. And x means basically the measure of one angle, and y means the measure of the other angle. You could use any letters. I'm just using x and y. So we're going to say the sine of x and the cosine of y minus the cosine of x times the sine of y. Now, and the other one we were looking at, they're using theta and phi, but for me it's just easier to write it in terms of x and y. So all I've done is change this to x and change this to y, change that to x, change that to y. Alright, so you're like, well, what's x and what's y? Okay, so I'm going to call angle ABC, I'm calling that my x, and I'm calling 60 degrees my y. So angle ABC will be x and 60 degrees will be y. You're like, well, what in the heck how am I supposed to find the sine of 60 degrees? Well, this goes back to our 30, 60, 90 triangle. So let me go over here. I'm going to create a 30, 60, 90 to the best of my ability. Alright, that's about half of an equilateral triangle right there. I'll call it 30, 60, and 90. And if you remember the chart of the 30 degree, 60 degree, 90 degree, I'm going to call it x radical 3, 2x, and I'll label them. That's your shortest side right there across from the 30 degree angle. This is your middle side, which is across from the 6th degree. That's x radical 3, and we'll call it 2x. And then we're just going to use numbers to make it as easy as possible. So we're going to call x 1, we're going to call this 1 radical 3, and we're going to call this 2. So basically, if we're going to use numbers, we're going to call this length 1, we're going to call this length radical 3, we're going to call the hypotenuse 2. Because 1 squared plus radical 3 being squared will equal 2 squared. So, it asks us for, we're going to have to find two different things. We are going to have to find the sine of 60 degrees and the cosine of 60 degrees. Because this is going to be our angle x, that's going to be our x, and I'm going to use this as our angle y. Right? So, what is the sine of 60 degrees? Well, let's check it out. If I go right here, there's my 60 degree angle, and I draw an arrow going across. What does this represent? This represents my opposite side, and this 2 right here represents my hypotenuse, and this 1 represents my adjacent side. So sine is opposite over hypotenuse. So the sine would be known as radical 3 over 2. And cosine is the adjacent over the hypotenuse. So the adjacent over the hypotenuse is 1 over 2. So the sine of 60 degrees will always be radical 3 over 2, and the cosine of 60 degrees will always be 1 over 2. So now I have all of my information that I need to finish this problem. I have all the information that I need. So here we go. I'm going to do parentheses, parentheses, minus parentheses, parentheses. I'm just going to, as I've written everything down, I'm going to take a look at it. And it says, what is the sine of x? Well, the sine of x is 4 over 5, so I'm going to put 4 over 5. And it says, what's the cosine of y? Well, the cosine of my y is 1 over 2, so I'm going to put 1 over 2. Now, it says, what's the cosine of x? Well, the cosine of x is 3 over 5. And then it says, what's the sine of y? Well, the sine of y is radical 3 over 2. And how do we get this? Remember, we got it from the 30, 60, 90, then we got it from this triangle. So now we just multiply things together. 4 times 1 is 4. 5 times 2 is 10. Minus 3 times radical 3 is 3 radical 3. And 5 times 2 is 10. Now you could write this as 4 minus 3 radical 3 all over a 10. That's one way you could write it. But we're going to simplify this fraction, and 4 over 10 becomes 2/5 minus 3 radical 3 all over a 10. Now I think they write it as 3/10 times radical 3, but that's going to be our answer. 2/5 minus 3 radical 3 over 10. So 2/5 minus 3/10 times radical 3, that's going to be our answer. We'll go on to another problem. Now this problem looks like we're going to be using the double angle formula. So what we have to do is we have to search for the double angle formula. So I'm going to take a screenshot of this. I'm going to go back to our chart real quick, and let's go down right here to the double angle formula. Okay? So we have cosine 2 theta. Cosine 2 theta. So we're going to write this down real quick. Take a screenshot. So I'm going to put cosine 2 theta equals 2 cosine squared theta minus 1. Alright? 2 cosine squared theta minus 1. And we're going to use this triangle right here. Now, it says, find 2 times angle BAC. Now, BAC is referring to this angle right in here. So once again, I'm going to draw my arrow going across. I'm going to label this as my opposite side. This is my hypotenuse, and this is my adjacent side. I'm going to write my trig ratios, SOHCAHTOA. So, what is 2 times angle ABC? So it's 2, and what we're going to do is we're going to take the cosine of theta, and we're going to square it, and we're going to put minus 1. So what is the cosine of angle ABC? Well, the cosine of angle ABC is the adjacent side over the hypotenuse. Well, what's the adjacent over the hypotenuse? That's 8 over 10. Well, what is 8 over 10 reduced to? That reduces 4 over 5. We're going to take 4 over 5 and we're going to square it. So we're going to take 4 over 5, we're going to square it, and we're just going to go ahead and simplify whatever that becomes. Alright, so here we go. We're going to do 2 times, now 4 times 4 is 16, so we'll go to 16 over 25. Now what I'm going to do over here is I'm going to put minus 25 over 25 if we're having to do this by hand without a calculator, because 1 is equal to 25 over 25. And then we do 2 times 16, which is 32. 32 over 25 minus 25 over 25, and 32 minus 25 gives us 7 over 25. So what I'm going to type in is I'm going to type in 7 over 25. We'll see if I messed up. You know, if I messed up, we'll find out. Let's see here, 7 divided by 25. All right. Okay. Once again, if you want to see a step-by-step solution, how they're doing it, looks like they used a different formula. They used cosine squared minus sine squared, which is just another derivative of that formula. So you could use cosine squared minus sine squared, or you could use this right here, which is 2 times cosine squared theta minus 1. Either one will work. Now, where did they get that formula, if you're wondering? They got it from taking the Pythagorean identities, taking these identities and rearranging things. Okay. All right, let's go on to our next problem. All right, this one says find sine 2 times theta. So it looks like we have the same exact problem. Actually, no, A, B, C instead of B, A, C. But very similar, very similar. So the first thing I'm going to do is I am going to find the sine of angle A, B, C. Just get that out of the way. Now, angle A, B, C is referring to this angle right in here. Draw the arrow going across. Label the opposite side. There's the hypotenuse. There's my adjacent side. Alright, so my opposite over my hypotenuse is also 8 over 10, which reduces to 4 over 5. I'm going to use that sucker right there. Let's go over to our sine of 2 theta. So we'll put sine of 2 theta. Not expecting you to memorize all these. Sine of 2 theta, it says 2 sine theta, cosine theta. Ooh, okay, I like it. Alright, so 2 sine theta, cosine theta. Well, it looks like we're going to have to find the cosine of angle ABC. Well, that's not that hard. That's the adjacent over the hypotenuse, which is 6 over 10, and that sucker reduces to 3 over 5. So there's our cosine of theta. So let's just write down 2. Our sine of theta was 4 over 5. Our cosine of theta was 3 over 5, and we just multiply top times top times top, which is 2 times 4, which is 8 times 3, which is 24. over 5 times 5, which is 25, and I'm going to type in 24 over 25. You're like, where did you get all this stuff? I looked. I'm going to, probably you didn't see it. I'm going to put it right here. Using this formula right here, the double angle identities. The other one we just used was this one. Okay, that's the other one that I used. So my suggestion is you click on the article, you write these down, you have them handy, and whatever one it asks you to use, you just use it to the best of your ability. Then, when you're done, you type in your answer. 24 divided by 25. Alright, let's do one more. This one looks like we're dealing with the sum of two different angles. Okay, so right here, I'm going to call angle BAC X. I'm going to call 60 degrees my Y. We are going to write down the cosine of X plus Y. And instead of theta and phi, we're going to do X and Y. So I'm going to go back over here. I'm going to look at cosine of their theta plus phi. So it says cosine cosine minus sine sine. Alright, so that's going to be pretty easy. There's your x, there's your y, there's your x, there's your y. Cosine cosine minus sine sine. Cosine cosine. Cosine of x. Cosine of y. Minus sine of x. And sine of y. I'm just going to make sure I got everything down. Cosine of x. Y minus the sine of x, sine of y, got it down, looking good. So now what we're going to do is we're going to angle BAC, we're going to find the cosine. Now, of BAC. BAC, that's this angle right in here. Angle BAC, also known as just angle A. Draw an arrow going across. Label that my opposite side. There's my adjacent side. There's my hypotenuse. Alright, so I'm just going to write, ready? Cosine of x, sine of x. That's what I'm going to do right here. I'm just going to kind of label what they are. So my cosine is my adjacent over my hypotenuse. So the cosine is going to be 5 over 13. My sine of x is going to be the opposite over the hypotenuse. So I guess I should have written SOHCAHTOA so you can see what I'm doing. So the opposite of the hypotenuse is going to be 12 over 13. All right. And then over here, what I'm going to do is I'm going to make my 30, 60, 90 triangle so we can see that relatively easily. All right. I'll even make a different perspective. All right. That's not too bad. We'll call this the 30-degree angle. We'll call this the 60-degree angle. There's the 90. And I'm just going to label this as 1. This is radical 3. And this is a 2. And that's from the special qualities of 30, 60, 90, which you learned in geometry and also reviewed this year in Precal already. There's your ratios, okay? And all we did was use a 1 radical 3, and a 2. Okay. All right, so there's my 60-degree angle. I'm going to draw an arrow going across. There we are. Label that as my opposite side. There's my hypotenuse. There's my adjacent side. All right, so I'm going to put cosine of y and sine of y. Remember, we're dealing with the cosine of 60 degrees and the sine of 60. That's what our y value is 60 degrees. So what's the cosine of 60? The cosine of 60 is the adjacent over the hypotenuse. That's going to be 1/2. And the sine of 60 is radical 3 over 2. Now I'm going to go back to our very, very first problem, which is right here. And you'll see that the sine of 60 is always radical 3 over 2, and the cosine of 60 is always 1 over 2. So once you have them down, it's not like you got to redo it. I'm just doing it again so you can still see the same problem. Okay. All right, finishing it up. So what I'm going to do now is I'm going to do some parentheses. Try to make it nice and neat. Alright, so here we go. The cosine of x. What fraction am I going to put in for the cosine of x? I'm going to put in 5 over 13. And right here for the sine of x, I'm going to put 12 over 13. And here for the cosine of y, I'm going to put 1 over 2. And for the sine of y, I'm going to put radical 3 over 2. And I'm just going to multiply these fractions together. So it looks like I got 5 over 26. I'm going to put 5 over 26. There's a little minus. Minus. Okay. We have 12 radical 3 over 26. 12 radical 3 over 26. Now this fraction can reduce. Not the 5 over 26. That can't reduce. But I can take half of that and get 6. And take half of that and get 13. There's my answer. Looks like my answer is going to be, oh, there it is right there, answer choice A. Alright, hopefully that gave you enough information to be able to use these double angle identities and angle and sum differences. Looks like we got a sum and a difference and then a couple of different angle identities. Alright, so I'll go ahead and select that, which was, I think, was answer choice A. And that's it. Hope this was helpful. You all have a good day.